Hello and welcome to this session. I'll be talking about the market for satellite IoT. This is a really exciting time to be in satellite IoT. There's lots of innovation happening in this space at the moment, lots of new satellites going into orbit, lots of new services being launched, hardware, software, that whole application, that whole ecosystem is exploding. And so in today's session, I'm going to be talking about some of the key challenges that's driving all of this innovation. I'm going to be talking about some of the markets and verticals that this innovation will be addressing. I'll also go through the ecosystem. Who are the key ecosystem players in here, whether that's hardware on the software side and on the satellite side, and what's the criteria for success? Obviously, with lots of players, there's going to be lots of competition as well. And so what are the criteria that's going to define success for all of these players? So with that, I'm going to be sharing a few slides to take you through that. A moment. So first, a quick introduction about myself and about ST Engineering iDirect. My name is Rajesh Suseelan. I am the Senior Director for Strategic Business Development at ST Engineering iDirect. iDirect is the satellite communications business within ST Engineering. As a company, we're over 35 years old with over 1,000 employees together. And our innovation and expertise is in satellite communications, covering a number of different verticals and applications as well. That's across enterprise, broadband, media, cellular backhaul, aero, maritime, and obviously IoT as well. The product portfolio is now branded as ST Engineering iDirect. That includes the iDirect brand as well as NewTek, which is a recent acquisition of ours. So looking at IoT, or the industrial Internet of Things, depending upon how you want to frame it, what do you do with IoT? And ultimately, IoT is about connecting things and connecting them to the internet. So when you're able to monitor these things, you can manage them better. So IoT is about, and ultimately it's about the business outcomes that can be derived from the information that you gather from these objects. So it's about real-time monitoring. Once you receive that information, you can act on that information and optimize operations. And that usually will lead to increased efficiency, whether that's reducing wastage or increasing the output. In many cases, automation removes the need for human intervention, and that leads to increased safety. But finally, it's about impacting the bottom line for the end user. So IoT is less about connectivity and all the other nice things that go about it. It's about how do you optimize and improve efficiency for the end user and ultimately impact the bottom line for them. So I wanted to kind of take you through some of the key use cases that the IoT is serving, and these are especially relevant to satellite IoT, given some of the challenges that terrestrial connectivity has. These are the key use cases where we're seeing a lot of adoption of satellite IoT. Transportation and logistics, for real-time tracking of vehicles, assets, where exactly are my assets, what's the condition of those assets, monitoring utilization, for example, in cold chain, in cargo tracking, environmental monitoring, again, doing air and water quality management, weather and environmental monitoring. Again, with the nature of environmental monitoring, a lot of these assets are distributed and in places where you don't have terrestrial connectivity available. Smart energy. So again, looking at the visibility into the generation and transmission of electricity or any other utilities in that, and smart metering is also makes a big play in that as well. Asset management, monitoring of your assets in real time, and that could be in mining, in construction, and it's also about tracking those and tracking the location of those assets and making sure that they are where they're supposed to be. Agriculture there's a number of different use cases in agriculture, whether that's tracking of cattle or proactive monitoring of environment or of the conditions. And again, this is about improving the output, improving the yield of those farms and reducing any input like water, fertilizers, and all of that, and optimizing that usage as well. And obviously automating a lot of the equipment and assets that you have on the farm. And finally, in maritime, where you find a lot of use cases for monitoring buoys, monitoring fishing vessels, the number of small scale fisheries that you have. So again, this finds a huge use case. Satellite finds a huge use case in monitoring of catch reporting of fish, for example. Finally, the biggest benefit from all of these different applications is the process and productivity improvements that come along with monitoring all of these. Now, I did mention at the beginning of this session that there's a number of different challenges that we're facing with global IoT connectivity at the moment. Obviously, with terrestrial connectivity, the first one is availability. You don't have connectivity where you need it and when you need it. So that's or the other option or the other challenge with that is the fact that it's unreliable. Cost is another factor. Now, traditionally, satellite connectivity has always come at a premium compared to the terrestrial options, and that's kind of limited the adoption for a lot of those use cases that I mentioned earlier. Power, in many cases, you need to kind of, in a lot of cases, what happens is you need to monitor something where there is no power available, and if you have to monitor something, you've got to build up your own power infrastructure as well. So how do you ensure that you can make, and finally, there's interoperability. How do you make sure that that any application that you deploy, any connectivity option that you deploy, you're able to retrieve that information and your application is able to understand that data and is able to consume that data. And finally, deployment. This encompasses a number of different things like ease of installation, ease of management, especially with these assets being deployed in remote locations. It's not always easy to kind of send somebody out to kind of check on things or to replace power or make changes to those equipment out in the field. It costs a lot more money to send somebody out to do that than to do it remotely. So these have traditionally been the big challenges with IoT connectivity, and this is where satellite connectivity comes in. Obviously, cost has been a major factor, but with a lot of the new services and new constellations that's going up, that's also coming down, as are some of the other challenges around power, interoperability, and deployment as well. I do want to kind of go through, how does satellite IoT work from a technical perspective. Satellite IoT works in very similar way as any other IoT service over terrestrial network, apart from the fact that the only limitation is that satellite is a lot more constrained than some of the terrestrial networks. At one end, you've got the sensors. These are the things that actually produce the event. So it might be a temperature sensor or a weather monitor. So these are the things creating the events or generating the information. This data is passed on either through to a modem, a satellite modem, or to a device or a terminal that's aggregating this data. And finally, that collects that data and transports that over the satellite network. Once this data is landed back on Earth, this data is then stored, analyzed, and presented either through an application gateway or into an IoT platform, from where this is presented to the end user as either as an application. And this is where all the intelligence happens, where the analysis happens, and where you can make more sense of that data. Again, it's also important to understand that satellite IoT services are not all the same. So it'll be useful to kind of look at the different ways in which satellite IoT is deployed. So there are two different models in which a lot of these deployments take place. The first one is what is called as an IoT aggregation model. This is a case where you have a number of devices, a number of endpoints, which are either connected through a single device, one single device collecting data from a number of different endpoints, or aggregating it through a third-party gateway device. Obviously, it's low efficiency. There's a lower density of terminals. There's a lower number of terminals that you can have in a network. Higher power means you can have higher data rates. So these are very suitable for localized deployments. For example, on a farm where you're collecting all of the data from all of the equipment on that farm. In vast majority of these cases, it's using IP protocol. And for example, the use cases here would be similar to what a BGAN or a VSAT would be used for. The second one is what is called as a direct-to-satellite model. This is where each device is connected via a modem and an antenna directly to the satellite. It's usually one device per connection, so it's one connection per device. This is high efficiency and you can have a higher density of terminals on that network. Obviously, it does come with some trade-offs. With lower power, it comes with lower data rates as well. However, with lower data rates, you can have a lot more devices on that network, and you can have, it's much more power efficient as well, running on smaller batteries as well. So these are, however, most of them do not support IP, and they support proprietary messaging protocols. And examples of these would be the likes of Inmarsat, IDP, SBD, Global Star, and all of these small sat IoT services. So when customers look at deploying a satellite network, I think it's the end customer sensitivity of these services is kind of driven by a couple of factors over here. Price is actually the first major issue that most customers come with. Now, usually the cost of ownership in an IoT is driven by hardware and airtime costs. And this is usually what drives the decision whether to go in for satellite connectivity or maybe some other forms of connectivity. Power consumption and installation integration, that drives up additional cost per unit for the end user as well. Next, it's the decision on how much data, what's the size of the data that you're going to be pushing over the satellite network, what's the payload size. There's also the question of frequency of the data and volume of that data, like how many times in a day does that data need to be sent? Is that going to be like once a day, or is that going to be like once every hour, or once every minute? So depending on that, there are considerations where you need to go in for something like a direct to satellite model or a aggregation model. Then finally, what sort of latency is tolerable for the application? Does the information need to be available immediately, or is some latency, let's say for example a 15-minute latency, applicable for this? And finally, reliability and criticality. This will eventually depend upon the use case. And for example, if an action needs to be taken immediately, you can't afford to have that 15-minute latency. So that's when that's when a lot of these deployments need to be a little bit more intelligent, where there's either you use something like an edge compute, which can take those decisions a lot more quicker, reduce the latency as well, or you go in for something like an IoT aggregation model. But eventually, as you can see, the sensitivity starts off from price and goes up all the way up for reliability. Looking at the IoT value chain, how do the different players within the value chain play with each other? And this will eventually have an impact on the success of the overall service and solution. First is the satellite network connectivity, where most of the operators would either be looking at either a bandwidth leasing model or IoT airtime sales. Hardware, again, we see a lot of different use cases here, where the vast majority of small sat players, small sat satellite operators would be looking at chipset or a module, and in some cases even going into a terminal, which is a fully packaged device which contains the modem as well as the antenna integrated into it. And finally, solutions integration. And again, in the solution integration space, it's looking at all of the different ecosystem players, whether that's the channel partners who are reselling some of your services, the software applications that can be integrated with the service, and finally the end-to-end user solution, whether that's in transportation, mining, or in utilities. How do you combine all these different elements together and take it out to market? In many cases, some of the service providers are, combining all three aspects of it: the connectivity, the hardware, and the integration together, and selling that into the market. In a lot of cases, they have an ecosystem of partners that are already building up to provide elements of this service. So coming down to the success criteria, what does it take to be successful in this market? So as I mentioned before, I think first and foremost is having a robust ecosystem of partners. You want to be able to deliver specific, applications for those use cases, for those target use cases. You need to be able to have a robust, ecosystem of developers and integrator partners who can take on your service, package them up, and sell them into those vertical markets that you're targeting. And finally, those technology alliances. So it's not just about what's up in space. It's all those. It's everything else. All those technology alliances, whether that's the infrastructure, the hardware infrastructure, or the application infrastructure as well. That would go into this specific service. And finally, business outcomes. It's about addressing some of those challenges that I mentioned earlier about ease of use. How is it? How can you make it easier for your partners to take on the service and deploy them, integrate their applications into this IoT service, showing measurable results. One of the big challenges with IoT is that a lot of them do not go past the POC stage. As long as you can start showing those results fairly quickly, and finally, return on investment. It takes a lot of effort to kind of put an IoT solution together. Ultimately, you've got to impact the bottom line for that end user customer. And with that, the final slide, IoT is, end of the day, satellite IoT, it's part of the larger, connectivity strategy. It's making use of all of the innovations on the ground. It's not just about everything up in space. It's also about making use of all of the innovations on the ground, like 5G, the ground infrastructure, all of those other, enablers like virtualization, orchestration, and to combine all of those innovations on the ground and in space. And with that, that's my last slide. I'll be around for questions. If you need to get in touch with me, if you have any questions, do feel free to reach out to me on my email there. Thank you very much.